PowerShell scripting, logical constructs. Now, PowerShell is not a scripting language, but it does contain a scripting language. And like many scripting languages, it features logical constructs. These are the things that allow a script to kind of make decisions. If this user is supposed to be in this group, then also do these other things with them. So we're going to look at the main logical constructs in PowerShell. Windows PowerShell really only has two logical constructs, the if construct and the switch construct, although the switch construct comes with some fun little variations that we'll play with too. Now, absolutely everything I'm going to show you here is applicable to PowerShell version 2 and later equally, across the board. I'm going to be using the Windows PowerShell version 3 ISE simply because I like it better. And I'm going to get it laid out with the console next to the script pane. It'll make it a little bit easier to kind of follow the example. So we'll start with a basic if construct. These kind of take the form of this. The keyword if, which is not case sensitive, a parenthetical expression. Now that needs to contain some kind of code that evaluates to either true or false. If it's true, then whatever you put in between the curly brackets will execute. So we need something to work with. I'm just going to retrieve a list of processes. Now that means in my condition here, I can say if procs.count is greater than 100, and we'll just write a little message. Right host, you have a lot of processes. And then we'll run it. I got no output, which means, presumably, I have less than 100 processes. Now, there's another addition you can put onto this if construct called else. Else gets its own set of curly brackets, but it does not get its own parenthetical condition. Else is what happens if this isn't true. So if this, do this. Otherwise, else, do this. So I run it now, and I get my output, less than 100 processes. Now you'll notice here in the ISE when I run this, the way it's running this is by actually kind of pasting in the contents of my script. And one of the reasons it does that is because that's largely how it works. But also, let me save this real quick. Call this constructs.ps1. Clear the screen. See, now when I run this, because I saved it to a file, it's just running the file. It doesn't have to paste the contents into the shell to run it. So this just looks a little cleaner. Plus, it's saved. Now if I screw something up, I have a backup plan. So in addition to the if portion, which is mandatory, you can have an else. And kind of in the middle, you can also have else if sections. And those look something like this. They get their own parenthetical and their own script block. And this parenthetical can be whatever you want. Let's say if procs.count is less than 5, right host, very few processes. I'm guessing I have more than 5, so I'm still expecting this to run. This will be false. Process count is not greater than 100. I'm expecting this to be false. Process count will not be less than 5. So then I should still fall through and print this. And I did. The thing is, you can have multiple else if blocks. So let's stick another one in here. And each else if block is its entirely own thing. Like these first two looked at procs.count, but I don't have to do that here. For example, if, let's take the first process, name like a star, I'm just curious here. Let's run get process and see if the first process does in fact start with A. So I know what to expect in my output. It does. The first one is called audio DG. So in theory, when I run this, the first proc starts with A. So part of the deal with this construct is only the first matching condition will execute. This was false. I do not have more than 100. This was false. I have more than 5. This was true. the first process's name did start with the letter A. So this executed, and then that was the end of the construct. Nothing else would even be evaluated. So you always start with an if. You can have as many else ifs as you want, and if you want to, you can end with an else that will take care of the, if nothing else has been true up to this point, go ahead and do this. So you can make these things as complicated as you want to. Now, it's not that uncommon to see folks use these. What's a good way? Oh, here's a good way. Let's go grab a disk. Get WMyObject class Win32 logical disk. Let's filter this so that I only get ones where the drive type is equal to local disk. Oh, actually, I don't want to do that. That'll take all the fun out of this. Let's just get the first one. Select first one. And then let's just look at disk. So I'm going to run this real quick. Oops, yes, go ahead and save it before you run it. So the first one is a drive type of 2. Here's what you'll see some folks do. If disk.driveType equals 2, drive is floppy. Else if disk.driveType equals 3, drive is fixed. And you can keep doing this. More else if. Disk.driveType equals 5, I think is optical, like CD-ROM. Else all right, so you can kind of build all these little logical things. And all this is doing is taking the same condition and comparing it to different possible values. So if we run this, the drive is floppy. Now, there's a little mistake here that some folks will make. Let's slide this over just a little bit. This only works essentially because I made sure that $disk contains one and only one object. And I did that by selecting the first one. Now, this virtual machine I'm running in, if we just run this portion here, which you can conveniently do in the ISE, right-click, Run Selection, this virtual machine has 3 disks. By selecting the first one, I ensure that disk has only one item in it. Look what happens in PowerShell version 3 if I don't do that. Save this, we'll slide this back over just a little, and we'll run it again. It's really only working off the first one anyway. It's not automatically running through all 3. Right? The idea is you're asking the computer to evaluate something. Is the drive type property equal to 2? Which drive? You gave me 3 of them. Now look, in PowerShell version 2, that won't happen. You'll actually get an error. PowerShell version 3 goes ahead and looks at this and says, well, this is multiple things. He's asking for a property. I guess I'll just take the first one. The point is you might not expect that as results. You might expect it to go through and give you each of those 3 drives drive type, but that's not what it's going to do. It's not going to implicitly do that. These constructs and this syntax where you're referring to a property of something is designed to work with just one at a time. Now, if you have multiples of something, we've already looked at the for each object command, which can run through them. For example, I might say pipe2 for each object, and then I'll wrap this entire thing as the for each object's process block, and then inside there, and then we don't need this here anymore. So what I'm doing now is I'm running getObject. I'm allowing all 3 objects to go to the pipeline. They're being piped to for each object. Inside the for each object script block, this whole thing, $_ lets me refer to one object at a time. I'm just putting that in disk for convenience. Now if I run this, it's going through each one. So you have to structure things differently if you want to compare multiple things. I'm going to undo all of that. Take me back to just my very simple where I was selecting the first one. So this is a very, very typical, very common if construct. This is not the only type of logical construct that PowerShell supports. There's actually another construct that's more specifically designed to deal with this situation. So I'm going to leave this here, but I'm going to comment it out. So PowerShell doesn't execute that. This other type of construct is called switch. And it starts off very similar with a script block and parentheses. In the parentheses, though, you're not going to put something that resolves to true or false. You're simply going to put the thing you want to compare to multiple possible values. Or if we're going to keep with the same example, it's $disk.drive type. I want to compare this to multiple different values. Well, you've got a couple of ways you can do that. It could be numbers, could be strings. I'm just going to say I want to compare it to 2, and then I want to compare it to 3, and I want to compare it to 4. If it is 2, if it is 3, if it is 4, so what did we, no, 5 was optical. And then this has another sort of catch-all situation called default. And that works kind of like the else. If none of these has been true, then it will execute the last one. You can see that this provides a somewhat more compact way of doing the same comparison. There's nothing stopping you from doing the neat little formatting like this. You can do that too. You can put it all up on one line. Because I only have one command being executed, it's a little bit more visually compact to run them on one line like this. But let's just save this, run it, see what happens. Floppy. So disk.drive type was 2, therefore floppy. So the switch construct is really similar to an if, else if, else if, else if, else if, where each of these is a different condition, and then this is your last sort of catch-all situation. But the switch construct is a little bit different. Remember with if, it will only find the first condition that's true, and the rest of them will not be executed. Also with if, each else if has a complete comparison all on its own. This particular one happens to be looking at disk.drive type in all of them, but it doesn't have to. I could say if the drive type is 2, do this. If the size is more than this, do this. If this is more, each of these can be a completely different situation. So switch works a little bit differently when that happens. And you might say, I don't understand how that could be true. Because it's impossible for drive type to be anything but one number, right? Well, that's why we're going to move away from a drive type example. Instead, I'm going to switch, and I'm going to add an option here called wildcard. And I'm going to switch on name. So name is the value I'm going to be comparing to multiple possible options, and I'm going to do those comparisons using a wildcard. Now bear with me because this will be interesting. I've decided that my company's file naming convention uses the word DC, or server naming convention, sorry, uses the word DC for domain controllers, FS for file servers. We add NYC for servers that are in New York, and LON for ones that are in London. Watch this. It's going to prompt me for my server name down here. Let's say it's NYC DC01. It knows that that's a domain controller and in New York. You see, unlike the if construct, switch will continue to evaluate every possible option, and it will execute all of them that are true. Run it again. London FS02. It's a file server. That was true because this wildcard match was true, and that was true because that wildcard match was true. So this is something you have to keep in mind with switch, is that it's going to evaluate every possible condition, and it will execute all of them that match. Now let's break this out so that each of these can take up a separate line all by themselves. And I'm just kind of lining up my curly brackets to stay a little bit neat. There we go. Now this is just formatting. I'm going to run this right now just to emphasize that absolutely nothing functional has changed. NYC-DC01 is a domain controller in New York. Now I'm going to add a command. Break. Break. Run it again. NYC-DC01 is a domain controller. It only executed this one. The break command tells PowerShell to exit the current construct unless the construct is an if construct, meaning break will exit. So what happened was we switched on name. It said, yeah, this wildcard here with DC, that's true. So our output is a domain controller, and then I exit the switch construct entirely. It never looked at this, it never looked at this, and it never looked at this. So you can use break to make the switch construct behave a bit more like the if construct. You can have it evaluate and execute only the first match, and then you can have it move on. Now there's some other neat things you can do with switch. I'm going to open up a regular window here just so we can have a separate place to play. Help about switch. So you get the basic idea here. Switch, you get the test value, condition, and then each condition is followed by curly brackets containing an action. But there are some options here that you can put. You can have regex, wildcard, which we've used. You can have it do case-sensitive matches on strings, and you can have it do exact matches. Regex is probably one of the more interesting ones to play with. In fact, let's just do a copy, and I'll open up a new one, and we'll save it. And we'll save it as regex.ps1, just so we have something different. So instead of minus wildcard, I'm going to add minus regex. Now at this point, each of my conditions can be a complete regular expression. And we talked about those in a previous nugget. The star is a very simple wildcard in a regular expression, so I expect this will work somewhat similarly. I'm going to take my breaks out, save that, and then run it. LONDC01. Ooh, boom. Regular expression is not valid. It does not like that. So what doesn't it like? Well, the thing is, in a regular expression, while an asterisk is still a wildcard, it's meant as a modifier. It means more than one of whatever came before the asterisk. So these asterisks in the first position aren't valid because they're meant to follow something. So I can take this out. Regular expressions, by their nature, are already designed to do a simple floating match, meaning if I just put DC, it's going to look for DC anywhere in the string. So let's just do that then. See what happens when we run it now. LONDC01. Whoops, I meant to do that as a dash. So now, as regular expressions, these are matching without having to put the wildcards at all. You can imagine you could get into some interesting situations here. For example, let's run it again. What if I had lun DCFS01? Oh, it's a file server and a domain controller, so it's able to find that. Now, let's say that the city always has to happen at the beginning. So we'll put a little start of string anchor, oops, in front of the city name. Run it again. If we do LON DC01, it works. It's a domain controller in London. But what if somebody tried to type DC LON01? Well, it knew it was a domain controller because this matched, but it doesn't know it's London because it's only looking for LON at the beginning of the string. That's what that caret does. It's a beginning of string anchor in the regular expression syntax. So this proves that PowerShell is actually evaluating these things as real regular expressions, not just as plain strings or plain wildcards. You can do a lot of different things with the switch construct. That's one of the reasons folks like it. It's a very visually compact way to take one thing and compare it to several possible values. Unlike a bunch of if, else if, else if, else if, else if, it can look at multiple conditions and execute every single one that's true. Now, that's not to say we couldn't rebuild this using the if construct. There's a dozen ways to do anything in PowerShell. None of them are technically wrong. Let's comment this out. If I needed to do this as an if, I might do something like this. If name match, that's the regular expression operator, DC, and then rather than doing an else if, because keep in mind, I want multiple conditions to execute if they're true, so I'm going to build each of those as its own separate standalone script or if construct. FS means file server, and then this next one was New York, and the next one was London. And so in here we're going to be matching caret NYC at the beginning of the string, and here is going to be caret LON at the beginning of the string. We'll run this, LON DC01, domain controller and London. And it executed multiples because each of these is a standalone construct. Now, I find this to be a little bit less visually appealing just in the script because I kind of have a lot of repetition here. You know, it's $name dash match every single time. This sort of stack of if statements makes me want to switch over to a switch construct because I think it's a more compact way to do it. But at the end of the day, neither of these is right or wrong. They're just slightly different approaches to the same problem. They both get the same end result. So whichever one you're more comfortable with using, by all means, use that one. So there's the if construct, along with its variations, else if and else, and the switch construct, along with its variations, like using the break statement, using the wildcard switch, or using the regex switch. They're both logical constructs in that they both help your script make decisions. There's really no situation where you must use one or the other. They're both capable of doing very similar things in certain circumstances. It's whichever one you prefer. Frankly, the most flexible of them is if. Really, you could probably forget switch completely and do just about everything with if you wanted to. But switch offers some nice visual compactness sometimes. So sometimes it's a way to just make your script a little bit easier to read or easier for someone else to follow. I hope this has been informative for you, and I'd like to thank you for viewing.